Hi everyone. Today we are going to move on and talk more about how we can solve recursions. Okay, well, and today's topic is the master theorem. Let's do a very quick review. Last lecture we talked about the merge sort, and for the merge sort, that is a recursive sorting algorithm, and this solution is kind of different to the old school sorting algorithm we talk about, for example, like the insertion sorting or bubble sorting. Well, the difference is now our main side is we want to break a big sorting problem into two smaller sorting problem. Say we have one big list, and now to sort that big one, we want to separate that into two small sublists. We want to sort both of them, and then we want to merge them together into a big final sorted list. And then for those two small sublists, we want to break them into even smaller ones. And well, this is one style of doing the recursion. That's called divide and conquer, right? So we divide one big problem into smaller problems, and then we break the smaller problems down into even smaller ones. So we break them down, and eventually we put them together and to solve the big problem. So that's the merge sort. And for the analysis of merge sort, and we find one of the tricky thing. That is, well, to get the Tn, which is the estimate of how many primitive steps we need to execute to get the sorting algorithm done, we have a Tn divided by 2 there. So to have the Tn, we have to figure out what is the Tn divided by 2. And because this is a recursive algorithm, we end up with a recursive Tn. This is not what we really want, because we want the Tn to be a polynomial of n, and based on this polynomial of n, and then we figure out the big O and big omega and put them together, we have the big zeta, right? So how do we solve this? How do we solve this recursive Tn? And there are 3 different ways. Number 1 is a substitution method, and remember, to do a substitution, you want to divide your working area into 2 parts. On the right side, you do a scratching, and you need to figure out what is Tn divided by 2. You need to figure out what is the Tn divided by 4, and you move on. And after you figure out one part, you want to copy and paste it to the left part, and then following the substitution on the left part, and then you do some massage, and then you may need to go to the right side and do another substitution and plug that into the left side again. This is the process of the substitution. Well, usually if you're kind of new to the resolving the recurrence, and then I recommend you to do the substitution. And once you are a little bit familiar with this process, and you can move on and do the iteration. And that is, you can throw away the right side, and then you just expand the recursion, and then do some algebra massaging, and then continue the evaluation, and then expand the recursion again. And that is the iteration approach. Well, it doesn't matter if you prefer the substitution or the iteration. When you work on those problems, one of the things you will find is, well, both of them require you to do a lot of writing. Well, I remember when I show my students how to do how to solve a recursion on a whiteboard. I literally have 2 huge whiteboard, and then I use one side to do the substitution and to do the main working area, and another whiteboard to do the substitution part, and then I wrote 2 whiteboard full of my solution. That's painful, and especially if you want to do that if you want to type your solution on the Word document, and then it will take some time. Okay, so today we want to move on, and we want to find a general way to solve any recursion, or hopefully any recursion, in a quick way without really writing a lot. And that is the master method. Okay, so our goal is still we want to solve the divide and conquer recursions, but we don't want to write a lot. And by the way, we are only talking about divide and conquer recursions in this type. Okay, well, do remember there are 2 main sides of doing recursion. Number 1, divide and conquer. And what's the number 2? Number 2, I call it getting one step closer, right? So for the divide and conquer, this means, well, to solve the Tn, to solve the Tn, and then you are breaking the Tn into two, Tn divided by 2. Okay, so you are dividing one big problem into 2 parts or 3 parts or 4 parts, it doesn't matter. And how about the main side of getting one step closer? You are holding one item and then you need to solve the rest of the n minus 1. So every time you are getting one step closer to the final goal, but only one item closer to the final goal. Okay, so today when we are talking about solving recursions, we only talk about solving this style of the recursions. So it is a Tn divided by b. Okay, so when we are doing the merge sort, and a is 2 and b is also 2, right? Okay, so let's see. Well, if we want to put a recursion into a general form, so there are a, b, and c. So if the size is the problem size is 1, and then the cost will be constant. And otherwise, well, the problem will be divided into several parts, and then we want to also put them together. So we just put the random two constant values here, a and b. And so a, t, n divided by b, and then plus is cn. So, well, and then if you have this setup, and you will find that the merge sort we are able to solve from the last lecture will be a special case of this one. So today we are going to discuss how do we solve this recursion. This is going to be interesting, right? So, well, we start from here, and after that, well, for the t n divided by b, what is that? So I'm substituting this n, and this n from using n divided by b, so I have this part. And then I want to massage that a little bit, so I have the a squared t n divided by b squared. Okay, and this part has an n, and this part has an n too. And then moving on, and how do I get the t n divided by b squared? So I want to substitute this n, and this n with n divided by b squared. So I got this. And okay, this is painful, but we can do some massage, and then we got this part. So that is n cubed t n divided by b cubed. And then plus, we have an n here, and then plus we have another n here. Okay, so now how do we solve the Tn divided by b cubed? And then we want to substitute this n, and this n using the n divided by b cubed. And we can move on and on and on. And eventually, if you see this pattern may not be that easy to see, so feel free to pause the video and do a further reading. But this is a pattern we are able to get. Okay, so we have this. And then, where do we stop? So we ask this question again. So where do we stop? We stop when this value is 1, right? So when the problem size becomes 1, and then we got stop, and at this time, k is log bn. Okay? And then this also means n is b powers k. Okay, and now we can plug in the n value using and substitute that with b to the k, and this is what we have. Okay, and then we do a little bit more massage, and then we got this part. Okay, so and for this part, okay, so we have the cn, and then parentheses we have a to k divided by b to k. And then a to k minus 1 divided by b to the k minus 1. And then eventually, we have the a squared divided by b squared, a divided by b, and then plus 1. Okay, so this part should be familiar to some of you, and I believe you should learn that in some of the algebra course. And then, well, let's have a discussion. The discussion is, well, we didn't really talk about A is larger or B is larger or A and B are the same. And remember, for the merge sort, we have A is 2 and b is also 2, right? So let's start from an easy case. What if a equals b? So if a equals b, a powers k divided by b powers k, that is 1. And then a powers k minus 1 divided by b powers k minus 1, that's also 1. And what are you going to have? So for all the values in this parentheses, they are all 1s. And how many 1s do we have? We have k plus 1 of the 1s added together in the parentheses. So if all the values in the parentheses are all 1s, and what will the Tn be? And then, well, this is really easy, and Tn will be Cn and then k plus 1. And what is the k value? K is log Bn, right? So we substitute the k using the log Bn, and this is what we are going to have. And then we expand that, and you will find that it is a theta n log n. So theta n log n, does that sound familiar? That is the merge sort, right? So merge sort is one of this case when a equals b. When a equals b, and then after doing all this manipulation, the equation evaluation, and we got this. So when a equals b, it could be 2Tn divided by 2 or 3Tn divided by 3. It doesn't matter. Eventually, we will go down here and we will have a theta n log n. So this is kind of an easy case. So how about another one? How about a is a smaller than b? So when a is smaller than b, okay, and then we want to use this formula, and this is formula earlier I say, well, you should have that from a algebra course, okay, and then if we have the sigma, the sum of x powers k minus 1, and to x power x cubed, x squared, plus x and plus 1, and this will be this equation. And after that, instead of using x, now we have a divided by b, right? So we just substitute this x with a divided by b, and then we are gonna have this. So when we have this, and remember, a is smaller than b. So what's the value range of a divided by b? A divided by b, a is smaller value and b is a larger value. So a divided by b should be somewhere between 0 and 1, right? And consider the k will be a large value. Some value, a divided by b, between 0 and 1. And it powers a k plus 1. If this k plus 1 is large enough, what will this value be? This value, a divided by b powers k plus 1, will be very, very close to 0. Okay, so how about we drop that? So if we drop that, and we will have this value will be smaller than 1 divided by a minus b, because we are dropping a small value, so this value will be slightly larger. Okay, and then, well, how do we evaluate this value? So again, 1 divided by 1 minus a divided by b. A divided by b will be a value between 0 and 1. So 1 minus a value between 0 and 1 will end up with another value between 0 and 1. So this value on the bottom is still between 0 and 1. So it's safe for us to consider this value as a constant. So if this value is constant, and then we have the Cn multiplied by a constant value. Okay, so that is a theta n. So what do we have? So if a is smaller than b, and then it's guaranteed this algorithm, the Tn will be a theta n, which means this is a linear time algorithm. So this is another case. And the number 3, how about when a is greater than b? So when a is greater than b, and then we want to work on this again. Okay, and then for this part, well, and a is greater than b, so a divided by b will be greater than 0. So and will be greater than 1, excuse me. And then this value will be greater than 1, but we have a powers k. And then when this k is large enough, and then, well, a divided by b will be the dominant term, and then we don't have to care about the -1 here and -1 here too much. And then this is a zeta a divided by b powers k. And what is the k? K is log bn, right? So we want to substitute this k with the log bn and see what do we have. So we have the cn, and then, we have the cn multiplied by a log n, a powers log n divided by b, and a b powers log n. And then remember, for the base number here, that is b itself. So b powers log bn will be n. So we have cn multiplied by a log n divided by n. And, well, we want to do a small trick here. We want to exchange this a with this n. So we just want to swap position of those two values, and then we have the n to the log ba. And moving on, we have the n to the log ba divided by n, and we want to move this n inside. So this n will cancel this n, and we have a zeta n to the log ba algorithm. And that is for the case when a is greater than b. Okay, so when a is greater than b, and this divided and conquer algorithm is a zeta n to the log ba algorithm. Okay, so let's put them all together. So in this case, we are trying to solve this recursion. Well, this recursion, you can have any value as a, b, or c. Okay? Well, but there are only 3 possible cases. Number 1, when a is smaller than b, this is a linear algorithm. And when a equals b, and then we have the n log bn algorithm, and usually we call that log linear algorithm. And by the way, the merge sort, this is merge sort is this case, so that is a log linear algorithm. And when a is greater than b, and then we will have a zeta log b n to the log ba algorithm. So those are the total 3 cases. Well, it sounds like it's already a lot, but we are not finished. Why? Because, well, we are discussing the a and b and the c. Well, and we are comparing the a versus b. But there's another part. How about this? So we are assuming that for the merge sort, after we have done the divide and conquer, there is a merging part, right? And we have discussed the merging part, that is a linear algorithm to merge 2 lists together into one sorted list. But how about for this aftermath part of the recursion? How about it is not a linear? It could be n log n, it could be n squared, or it could be a constant. Okay, so in this case, how do we solve the recursion? That is an even harder problem, and we have to use the master theorem. Okay, so I'm gonna stop here. So this video, we only talk about this case, and we feel this divide and conquer algorithm might be hard enough, but be careful, we are only talking about the linear aftermath part after the divide and conquer. This is not true. So in the master theorem, we are discussing even harder cases of this term. Okay, so I'm going to stop this video here, and I will continue in the next video.